All right, so another solving of a logarithmic equation. This one has ln in it, which as long as, I need to recall that the ln is really the natural log or log base e. And so for some of us that aren't yet comfortable with that, it really helps for us to write it that way, because that way we can clearly see the base. And as soon as I see this, it really is like it's a single logarithmic equation. There's a single log. I could really convert this to exponential form, which is indeed what I'm going to do here. So I'm going to go ahead and change this. And as soon as I do, I know that e to the second power equals x plus 1 quantity squared. Now, I'm tempted at this point. What I notice, making use of structure, I notice that each side is really something squared, right? I can see that. And so I'm tempted, very tempted, to go ahead and just say e equals x plus 1 because I'd be making use of structure, okay? But if I did that, I would be ignoring the fact that in theory that square is going to take anything that's negative and ultimately make it become positive. And so, that might not be the case. So instead, what I could do here, if I'm solving this, I've got lots of options. I could, it looks like a quadratic to me, right? I could square that out, so I could treat it like a quadratic. That's an option, I've got another option, like I could always get rid of the square, cancel out the square, so cancel out the square. I just want to be careful not to use just the pure structure here, unless I realize something. So if I use the structure here, what I could do is I could realize that, x plus 1 could either be positive or negative e. Because if it was positive e when you square it, you get e squared. And if it was negative e when you square it, you'd also get e squared. So I think this is the simplest route, because then ultimately I would just say x equals e subtract 1, or x equals negative e subtract 1. And that seems like it would work, okay? So, seems like that would work. As a matter of fact, I could go ahead and check it if I kind of put it in. So I'd have natural log of, it'd be e minus 1 plus 1, right? Because this is my x value there. Squared equals 2. So that would just really be natural log of, that's just e squared equals 2. And that's a true statement, because what's the exponent on e that made 2? Well, there's that 2. Or what's the exponent on e and e squared? It's indeed that 2. Similarly, I could check my other one. So it'd be negative e minus 1 plus 1. And that's squared equals 2. So this would be natural log of negative e squared, right? And indeed, this has become natural log of e squared again equals 2. And that is indeed true also. So this checks. I like that. It's probably the simplest way to go about this question. But let's say you didn't see that. I could always cancel out the square, if we do that one. So I know e squared equals x plus 1 quantity squared. Maybe I'm just going to go ahead and square root both sides. And when I do this, I just really need to realize that in theory it could be positive or negative on each side. But, and I've got to put parentheses there. I could really just say, if you run the combinations, you run the different combinations, you'll end up finding that positive or negative e would equal x plus 1. So you're going to get some redundancy. And that ultimately leads me straight back to where that was. So I could do that. And then the last one, I could really look at it as a quadratic. That's doable. It's just kind of annoying. So you could do that. I don't think it's as efficient, but if you wanted to, you could indeed square it out and say e squared equals x squared plus 2x plus 1. And then you could go ahead and solve this. I'm just not going to do that because I don't think it's very efficient here. So anyway, hope this video helps.